Hello and welcome back all of you my dear students to our new video. Now, as we are learning about how seasons occur on this planet. In the previous video, we have discussed about what are the few elements that affect these seasons on our earth. In that I told you about two major things. The first one was the revolution of the earth around the sun. The revolution of the earth around the sun occurs in an elliptical orbit. So it means that at one point of the revolution, the distance between the sun and the earth is different, and at the another point it is different. It means it keeps on changing the distance of the sun from the earth. Okay, it keeps on changing. The second thing I told you is about the axial tilt of the earth. Axial tilt, it means if something is like this, it means it is perpendicular. Okay, it is straight in this direction. So if something rotates like this, then what we'll say, it is rotating perpendicularly. Now let's say something is tilting, okay, at a particular angle. Now this was 90-degree angle. Now we will just tilt it a little bit here. So what we can see, instead of this straight position, it is a little bit inclined in this particular direction. So what we say, this thing is called as the tilt. It means now the earth has moved like that and it will rotate in this position. So what happens due to this tilt, we will see in very short time, and we will see what are the effects of both of this revolution and the tilt of the earth. Now due to both of these things, what happens is that the sun now due to both of these things, what happens is that the sunlight that both of the hemisphere on the earth, okay, the sunlight that will reach to both of this hemisphere of the earth will be different in different position. If the earth is tilted like this, so what will happen, like you see, if here is the sun and the rays are coming like that, so what we will say that this part will get a little bit more number or more amount of sunlight, and this one will get a little bit less. So what happens, if this has gone near the sun and if it is away from the sun, this part will get more heat. Now in the same case, if the sun was on this side, let's say we will take it like this only. Okay, if the sun was on this side, so what we can see now, this part is near sun, so this will get more sunlight and this will get less sunlight. So like I have shown you like that, this only, but don't worry, I will also show you. So you see, this is how it works, like in very simple general layman terms. Now we will look at it in a much detailed way in the photograph that I will show you and in the videos after that. So let's get into it. So as we were discussing about the orbit of the earth around the sun. Now in the above picture you can see that on one side the distance of the earth is more and on the another side it is less. Now this thing particularly is called perihelion and aphelion. Now what is perihelion and aphelion we will discuss. On this side you can see the distance of the earth from the sun. Okay, distance between both of them is less. So this position or the position in the orbit of the earth where the distance from the sun of the earth is less, this position is called as perihelion position. It means this earth is very close to the sun at this point. Now on the same case in the another side, okay, in the opposite direction, the point you will see over here is that this point is the point at which the earth is the farthest away from the sun. Now it means the distance between the sun and the earth is maximum in the entire orbit. So this is called as the Ephelian position. Now if you say that yes, the distance between the sun and the earth is increasing and decreasing each day, it is moving around the orbit in the elliptical orbit around the sun. So you say, what is the maximum distance of the earth from the sun and what is the minimum distance of it? So the minimum distance, that means the perihelion position, is about 147 million kilometers from the sun. It means the earth at its closest position in the orbit, it is about 147 million kilometers away from the sun. And on the opposite side, when we say it is on the aphelion position, which is the farthest point in its elliptical orbit, so we will say that it is about 152 million kilometer. Now this distance you see is just having the 5 million kilometers difference between both of them, okay, between the nearest point and the farthest point. But you see, the major impact of the season is due to the tilt of the earth. As I have told you in the very first video itself, is that the orbit of the earth around the sun does not make much difference. It is contributing a little bit less, but still the tilt of the earth is the most important thing that we have to understand, because this is where you see we will find how do we get all these seasons all around the year. Now let's see another photograph. Now in this photo you will see that the earth is not straight, or it is not perpendicularly rotating. It is tilted at about 23.5 degrees. Now what does this tilt is going to do with the earth? Now due to this tilt, what happens is that the amount of sun rays that our earth will get will be different at all the different places. It means you see the sun rays will be falling perpendicularly on the equatorial region. Then the sun rays will be falling at a shallow degree of angle on the places that are above and below the center of the earth. It means the more farther away you go from the equator, the less degree of sunlight you will get. It means the degree of the inclination of the rays of the sun will be reducing, and in that what happens is that the amount of sun rays will be reduced, and also the amount of heat that we receive will be reducing in that particular place. So that is why you see the equatorial region gets a lot of sunlight and heat during entire year. So that is why you see in some places like the North Pole and the South Pole, there are all this 6 months of day and 6 months of night. So why it is so? It is just due to all this tilt. Now how it happens, that we will see in the video that I am going to show you now. Now, as I have explained you this part in the images, now we will move on towards looking at how does it looks like in actual terms when our earth is revolving around the sun over the entire year. So we will see what are the changes that the earth goes through in receiving the amount of sunlight in all this particular revolution that goes around, with added the tilt of the earth.
You know that Earth orbits the sun, right? And that it takes a full year for our planet to complete its orbit. Earth also rotates like a slightly tilted spinning top. Earth remains tilted in the same direction all year round as we orbit the sun. But that means the sun's light shines differently on Earth at different times of the year. Let's look at Earth when it's winter in the northern hemisphere. Observe how the North Pole tips away from the sun. This means that sunlight strikes the northern hemisphere at a shallow angle for a short period of time. This is why winter weather is generally cool, with short days and long nights. As Earth orbits the sun, we move towards spring in the northern hemisphere. Now Earth is tilted neither toward nor away from the sun, as day and night are about equal in length. As we make our way to the summer months, notice that Earth is still tilted in the same direction, only now on the other side of our orbit. The North Pole is tipping toward the sun. Sunlight strikes the northern hemisphere more directly, and the sun stays in the sky for a longer time. Compared to winter, summer days are warmer, and the sun stays in the sky much longer. Notice too that while it's summer in the northern hemisphere, it's winter in the southern hemisphere. Because of Earth's tilt, the seasons are reversed. We observed how Earth's tilt creates the different seasons throughout the year. How does this affect life? Plant life and other photosynthesizers, we call them primary producers, depend on sunlight. They respond to the changes in the seasons. Earth-orbiting satellites measure the amount of carbon dioxide absorbed by these primary producers. Bright regions on this map show where they devour the most carbon dioxide, turning light from the sun into oxygen and natural sugars. In spring, when sunshine strikes the cold waters of the North Pacific, productivity skyrockets. Phytoplankton and other microscopic photosynthesizers form the base of the ocean food web, and all ocean life responds to changes in the seasons. On land, forests grow green during the spring, brightening the continents. During winter, continents in this view turn dark from a lack of photosynthesis.
Now I hope you have got the idea of how it happens in this nature. That the sun is at one place only, if we look at it, but the earth is moving around the sun, and due to the tilt that it have got, you see how the differences are there, that these things will get all different sunlight all throughout the year. So that is how it goes on around like this entire year, and that is why you see the cycle goes on continuously. Summer, then rainy, then winter, again summer, rainy, winter. These things goes on due to this same effect. Okay, the same thing goes around entire year and year and year. It is all cyclic, because you see the nature is a spiral and it goes on continuously. So that's all for our today's video, and in the next video we will be learning about what is equinox. Now in this video we have learnt about the aphelion and perihelion position in the orbital revolution. But there is also one point in the orbit, and on that point the distance of the sun from the earth is equal in both of the cases. So what is all these things, the equal distance of the sun in particular phase of the orbital motion, and what is the equinox? This term is what we will learn in our next video. So until then, have a nice week ahead, and bye.